Hello, I'm Mike Scott, and this is the Accumetrics AccuTemp system model AT-7800. It installs on the rotor of a large industrial motor and wirelessly transmits rotor temperature to your controls. No slip rings or guesswork. While DC motors are the most common application, you can also deploy it on synchronous and induction machines across mills and plants. Why measure rotor temperature? If it runs too hot, you risk insulation breakdown and costly damage. Overheating can come from running above rated load, low supply voltage that drives higher current, worn brushes on the commutator, shorted turns in the field windings, or blocked air cooling. It's also valuable during restarts. If you know the rotor has cooled, you may restart sooner instead of waiting the full recommended time. The AccuTemp system transmits direct temperature measurements on the machine's rotor and poles using wireless telemetry and induction power. Up to 8 RTDs and their wires are bonded to the rotor and routed to the push terminals on the rotating transmitter. The antenna installs around the transmitter, powering the RTDs and receiving their measurements. The AccuTemp system transmitter is a split clamp collar made of G10 FR4 industrial laminate. It is a very high strength material designed to withstand high CFM cooling air. It has excellent electrical properties and exhibits low thermal expansion. It is expected to last over 20 years once installed. The transmitter collar rotates with the shaft and has spring-loaded Phoenix contact connectors for the temperature sensor inputs. The antenna is also made of G10 FR4 industrial laminate. It has a visual indicator on the collar that confirms it is receiving signal from the transmitter. The induction power supply pushes power across the air gap between the antenna and transmitter. It requires no batteries, and the powerful signal has a wide alignment range. The receiver enclosure houses the system's 8-channel data acquisition unit that measures the digital radio signal. Inside is a local display and Modbus TCP connection. Modbus TCP can be converted to other protocols such as Profibus and CAN bus. We also have options with 4 to 20 milliamp analog outputs. Power is brought to the receiver. The system is always on even if the motor is not. Thus, operators can use the temperature measurement to ensure the rotor has cooled enough before a restart. Here we see the system connected with enclosures open. The antenna is connected to the induction power supply, and the induction power supply connects to the receiver enclosure. In this demonstration, we have channel 5 connected to our Fluke temperature simulator, currently simulating a PT100 RTD at 300 degrees Fahrenheit. And if I increase the temperature to 310, 20, 30, 40, and 50, you'll notice that channel 5 responds on the display in time. This is the AccuTemp software interface. All 8 RTD channels are displayed at the top of the screen, currently in degrees Fahrenheit. The only active channel is RTD number 5, and we're simulating 300 degrees Fahrenheit and measuring 302 degrees Fahrenheit. You see I am getting some interesting status messages from the other channels. Those are not currently wired. Only RTD 5 is active. I can change the scaling to degrees Celsius by pressing this button here, and it instantly changes to a Celsius measurement, almost 150 degrees Celsius. On the bottom of the screen, we have a time-based waveform currently set for channel 5 using this drop-down menu, and you can see I've been increasing and decreasing the temperature between 150 and about 180 degrees Celsius as I prepare to record. Currently at 150 degrees Celsius. If I wanted to start logging the data, I could press this button and it will log the data to wherever I choose as a CSV file, so I'll do that. And then let's increase the temperature to 350 degrees Fahrenheit, and you can see that the channel immediately responds and is measuring 177.6 degrees Celsius, and the time-based waveform also immediately responded to record that increase in temperature. If I were to press stop logging at this point, I can show you what the CSV file looks like. We'll just expand column A to show the PC time. And again, we're interested in temperature number 5, which is column number F right here, or letter F, excuse me. And you can see the increase in temperature was recorded. And of course, from here, I could create anything I wanted in Microsoft Excel, graph or plot for all of the temperatures if I wanted to. So it gives you a lot of flexibility. And that's the AccuTemp software. Whether it's pushing the envelope on service factor or waiting the minimal amount of time for the rotor to cool before restart, the AccuTemp Rotor Temperature Monitoring System allows operators to achieve maximum performance from their large industrial motors. For more information, including helpful videos on our industry-leading earth fault resistance monitoring system for turbo generators, please visit AccuMetricsWithAnX.com.